All right, this is section 10-2, areas of trapezoid, rhombuses, and kites. So let's start off with a review of vocabulary. So is a rhombus a parallelogram? Yes, it is. Are all rhombuses squares? No. Are all squares rhombuses? Yes. So cross out the figure that is not a rhombus. So remember, a rhombus, all sides are congruent, so this one is not a rhombus. So a kite is a quadrilateral with two pairs of congruent adjacent sides. You can find the area of a kite when you know the lengths of its diagonals. The name of this quadrilateral is taken from the name of flying a toy that looks like it. All right, so circle the kite. So the one that it's a kite is this one. So the adjacent sides are congruent. So these two here would be the adjacent sides, and these two here would be the adjacent sides. So the figure at the right is a kite. What is the value of x? So x equals 5. A kite has two pairs of congruent adjacent sides. Okay. So our new formula in this section is the area of a trapezoid. So the area of a trapezoid is half the product of the height and the sum of the bases. So A equals 1/2 h times the sum of B1 plus B2. All right, so the bases of a trapezoid are parallel. The height of a trapezoid is the perpendicular distance between the bases. Okay, so what is the area of a trapezoid with height 7 and bases 12 and 5? So what we're going to do is use the formula, A equals 1/2 h times the sum of the bases, and plug in the information. So we have 1/2, the height was 7, and the bases are 12 and 15. We're going to first add the bases together. 12 plus 15 is 27. And then we're going to multiply everything together, and we get 94.5. So the area of this trapezoid is 94.5 centimeters squared. All right, so if we have a right triangle here. So suppose H decreases in trapezoid PQRS so that the measure of angle P is 45 degrees, while angles P and Q and the bases stay the same. What is the area of trapezoid PQRS? So measure of angle P is 45. Is the triangle still a 30, 60, 90 triangle? No. Is the triangle a 45, 45, 90 triangle? Yes, it is. Are the legs of a 45, 45, 90 congruent? Yes. So the height of the triangle is 2 meters. So the area is found below. So we're going to use the formula. Okay. All right, then we're going to substitute in the values that we're giving from the problem. Okay, then we're going to add the bases together, and then we're going to multiply or simplify. Let's use the word simplify. So then our area of the new trapezoid is 12 meters squared. All right. So the formula for the area of a rhombus or a kite is simply 1/2 the product of the diagonals, D1 times D2. All right, so instead of using the height and the length of the base, you use the lengths of the diagonals. Okay. So in number 18, the lengths of the diagonals of the kite are going to be 2 plus 4, which is 6, and 2 plus 2, which is 4. In this one, we get 4 plus 4, which is 8, 3 plus 3, which is 6. All right, so what went wrong in this problem? Okay, so if we know the diagonals are 12 and 9, they did the sum of the diagonals, not the product. So the student added the lengths of the diagonals instead of multiplying them. So what they should have done was this: a equals 1/2 12 times 9. So a equals 1/2 108. So a equals 54. The area of this kite is 54 inches squared. All right, so a rhombus has side lengths 10 centimeters long. If the longer diagonal is 16, what is the area of the rhombus? So the diagonals of the rhombus bisect each other and are perpendicular. So label this at the right. So we know that the sides of the rhombus are 10. So we can fill in all of these blanks. And if we know the entire length of the longer triangle here, the longer diagonal is 16, each of these have to be 8. Okay? So the shorter diagonals, x and x, or 2x. So we're going to use the Pythagorean theorem. So we have x squared plus 8 squared equals 10 squared, because each one of these is a right triangle. Okay? So we have x squared plus 64 equals 100. Subtract 64, we get x squared equals 36. So we get x equals 6. So therefore, the area of the rhombus is 1/2 the product of the diagonals, 12 times 16. So a equals 1/2 of 192. So a equals 96. So the area of this rhombus is 96 centimeters. Okay, so do you need to know the length of the sides to find the area of a kite? Cross out the length you do not need to find the area of each triangle in the kite. You do not need the hypotenuse. Okay, so no. Each side of a kite is a hypotenuse of a right triangle. You need only the length of the legs to find the areas of the 4 right triangles that are formed, or that form, the kite. And that's the end of this section.